Part 3 of problem 1, we're now told that our die has only been rolled 30 times. So A is the average of 30 die rolls, independently, of course. A prime is the best Gaussian or normal approximation to A. And we're asked, how often does A prime fall between 3 and 4? What's the probability that A prime is between 3 and 4? Well, again, let's start by finding the expected value and standard deviation. The expected value of A prime is going to be the expected value of A is the expected value of a single die roll, halfway between 1 and 6, it's 3.5. The standard deviation of A prime is going to be the standard deviation of A, which, as we saw before, will be square root of 35/12 divided by the square root of the number of die rolls, or in other words, approximately 1.7, or the square root of 30. Which is approximately 0.31. My handwriting is terrible, I know. So now our question amounts to, what's the probability that A prime falls within a certain number of standard deviations of its mean? Note that the interval we're looking at is centered on the mean of 3.5. How many standard deviations? Well, this comes to a distance of 0.5 out from 3.5, both above and below. So if we look at 0.5 over 0.31, we find that this is approximately 1.6. So we're interested in the question of how often a normal variable falls within 1.6 standard deviations of its mean. And now we can just go consult a normal variable table. Or, like I said, a normal variable calculator in the 20th century. But we're not at a normal variable calculator. We're at a normal variable table. And this normal variable table tells us that 94.5% of the time, approximately, a normal variable falls below 1.6 standard deviations above its mean. So let's say here's 1.6 standard deviations above the mean, 1.6 standard deviations below the mean. (94.5% of the time, it falls below 1.6 standard deviations above the mean. That means the remaining 5.5% of the time, it falls above 1.6 standard deviations above the mean. And symmetrically, 5.5% of the time, it falls below 1.6 standard deviations below the mean. So overall, about 11% of the time, it falls outside 1.6 standard deviations from the mean, which means about 89% of the time, it falls within 1.6 standard deviations of the mean. So our answer is approximately 89%. Ideally, you'd have this sort of calculator available to you where you could just say, how often does a normal variable fall within 1.6 standard deviations of its mean, and it could tell you 89%. But if you didn't have such a calculator, you could transform this question, as always, into a problem about the probability of falling below a certain quantity in a standard normal random variable, and then use a table given in that particular form. That's all that this last bit of rigmarole was about. But the answer to part 3 of problem 1 is approximately 89%.